Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 5, Section 6, Proving Triangles Congruent by something called ASA and AAS. So there's this idea of angle, side, angle. If we know that two of the angles of one triangle are congruent to two of the angles of a second triangle, and the included side are also congruent, then the two triangles are congruent. And remember, when we talk about included, we're talking about between. Here's another way of stating that. Two angles are congruent and the included side. There's also another theorem that says if we know two angles and a non-included side are congruent, then the two triangles are congruent. So once again, we have not included, so that's not between. Then we have two triangles being congruent. Angle, angle, side. So now we have two more tools, angle, side, angle, and angle, angle, side. Which one of these are congruent? Well, on the first one here, I've got two right triangles. So right away you think, ooh, it must be hypotenuse leg. But the hypotenuse we don't know anything about. It doesn't have any marks on it. But we do have this angle here, and we do have this side here. So this one is going to be angle, side, angle. That shows that both of those are congruent. The second one over here, I have a reflexive side AC, then I have an angle, and then I have a side. So I have side, angle, side. So that's what this one would show. This third one over here, I've got a side, and I have a reflexive side. This can be shown congruent by side, side, side. We have many different ways that we can show that two triangles are congruent. Let's actually use the ones that we just learned, the angle, side, angle, and the angle, angle, side. So what I have is two triangles I want to show are congruent. I have a congruent side here. I have parallel sides. And let's see what we can do with that. So I have my parallel sides AD and CE, and then my congruent pieces here BD and BC. I can use the fact that I have parallel sides to say that angle ADB, which is this angle here, is going to be congruent with this angle up here because of alternate interior angles theorem. I can say that I have two angles in here that are congruent because of vertical angles congruence. And once I have that, then I have my angle, side, angle to show that these two triangles are congruent. Let's try another one. This is a right triangle and this is a right triangle. So, and I have a midpoint. So let's actually go about proving that the two triangles are congruent. So I first state that they're all the given. And then I have a definition of a midpoint. A definition of a midpoint says that this and this are congruent. RV and VU are congruent. Angle S and angle T are right angles by the definition of what we have for perpendicular. And we know that all right angles are congruent, so we can say that S and T are congruent angles. So we can say that this is congruent to this. And then we also know, because of vertical angles, that we have two angles here. This angle and this angle are congruent. So now I have the situation of angle, angle, side. and that will show that the two triangles are congruent. So let's just summarize some of the theorems that we have. We've got side angle side. We have side side side. We've got hypotenuse leg of two right triangles. We also have angle side angle. And then we have angle angle side. And that completes our 5 different theorems that we can use to show that two triangles are congruent with just 3 pieces of information. We don't need all 6, all the sides and all the angles to show that they're congruent. And we'll continue this discussion in class the next day.